going into the auditorium. You'll have your groups assigned at that time. If you have a backpack, please leave those in the commons by the athletic hall of fame plaques. Do not take your backpacks to the sessions today. You will not need those. Leave them in the commons by the athletic hall of fame area. Lunch today, pizza, pasta bake, rib patty sandwich, barbecued rib sandwich, and ham and cheese stuffing. Sophomore, junior, and senior, you'll have regular lunchtime. Freshmen, you will all be in sessions. You will eat as a group after the other groups are done at around 12:15. You'll line up that one. There'll be no Spartan grill today. No Spartan grill. Everything is in the main line. Try out for the dance team. Held on Wednesday, the 27th. After school, open to all current 8 to 11 grade girls. They had their first practice yesterday. Also have one tonight after school at 3:30. Have to attend one of those to attend the tryouts. Contact Coach Jeffrey with any questions. Juniors, those of you who want to run for student body officer positions, make sure you pick up your nominating petition in the main office. By the close of business Monday, May 13th. You're elected president, vice president, secretary, treasurer. Mr. Gainey or Mrs. Applin, if you have any questions. Elections will be Tuesday and Wednesday, May 14th, 15th on the move. This week's Spartan lifters of the week are Jocelyn Ford and Carter Lyon. Both who show great dedication to the program, each having busy schedules and extracurricular activities, and still made the time to train for the next season of ball. Great work from Jocelyn and Carter. Fine Arts Gala this week, 6:30 to 8:30 Thursday night. On our fine arts students. Many of you received invitations in the mail and may pick up your free ticket in the office. You can buy additional tickets for your family, $5 in advance and at the door. National Honor Society meeting this week, April 27th, during lunch, Mrs. Lightford. All members need to attend, you're required to attend, and you have to bring your service hours forms. If you're interested in Dickinson State University, it'll be a rep here on Tuesday, tomorrow during lunch. Want to learn more about DSU? Stop and visit with the rep from Dickinson. West River Health Science Center offering 4 summer camps for students to learn about nursing and healthcare careers. 2 in Rapid City, 1 for middle school and high school, 2 in Spearfish, again 1 middle and 1 high school. Summer camps are day camps and are free to attend. The application is due May 2nd. Posters about the camp to hang outside Bishop Banton's classroom on the bulletin board. All, please stand for the pledge. Please, to the pledge. All have a great day.
Would you allow me, like halfway through class, to take a really long bathroom break? I forgot something for a class, and we might have to run and grab it.
Maybe.
Okay.
We'll see how things are going. Anyone still going? Should be fairly quick. All right. Now you get to make the axes however you want, and that was actually our last example that we did on Friday was, what if you try to fit it to someone else's axes and it ends up looking kind of gross? So the way I'm going to do it is make a normal tangent function, or arctangent function, with negative pi over 2 and pi over 2, 0. Green? Green. Yeah, green. I'm going to put 0 in the middle, and my amplitude, I'll just say, was 1 and negative 1. Halfway between intercept and asymptote, it'll hit negative 1 and 1 respectively. Okay, so that's a parent function. How do I change it because of this x over 2? What's that do? Reciprocal of b is, in this case, 2, and that is my vertical or horizontal stretch or compression. So all I do is change this to a negative 2 and 2 to make it go out twice as far. How do I use that plus 2? Okay, so we add 2, we add 2, we add 2. That's it. Done. Now it does ask us to label the asymptotes and the intercepts, so our points are going to be, did you leave them, no, not 2 of those. Did you leave them in compound form? You have the correct asymptotes and they're in compound form. Because that's a simplified expression. That's the correct part of it. Did you get your horizontal stretch to it? Labeled. Did you... You know what? I'm just going to say, did you have asymptotes actually marked, or did you not show them at all? Because that's kind of a big deal. We cannot cross those asymptotes. Is it the arctangent graph? And then I'm going to leave another one for, you had your words. The middle of that graph is labeled as a 0. The middle of that graph is labeled as a 2. What usually happens is kids will accidentally, they'll just do the ones to the extremes. They'll do far left, far right, far up, far down, and they won't have the 0 or the 2 in there as well. Because we are talking about intercepts, you need those because that's going to be my y-intercept in this case. So 5 things, 5 points that are hopefully easy. Questions about it? Cool. Then poke. I was asked nothing. Speak now or forever hold your pieces. Anything? Well, all right. In preparation for today, I brought out the old geometry notes. Okay. I said I always have my notes for the chapter. Well, they're about 10 years old, but this was my geometry notes when I taught it. I've been told that, who is it? Work, I think, gives my geometry notes out to kids still. All right. In there, I keep saying the words "you should have" and geometry, and we keep doing blank stare. The holy sheet of trigonometry. This is all stuff that we've done before. Our right triangle similarity stuff, Pythagorean and Pythagorean triples, our special right triangles, right triangle trig, angles of elevation, depression. Every now and then I bring up vectors and kids just look at me blankly because in our school, I think the first time you see those is in physics. That's a geometry thing. Today, we're going to finish off 4-6, and it should be fairly quick because we already got the graphing out of the way. And we're going to move our way into law of sines, law of cosines. Now, I know you've seen them before. I don't know if you did the ambiguous case for law of sines. So, we'll see how far we get. It's just finish 4-6, head into 4-7 as much as we can do. Tomorrow, theoretically, finish off 4-7. Wednesday, Thursday, 6-1. So, we got through our graphs. Okay, now I'll back up to this page. Okay, so right in between examples 3 and 4. And on Friday, I had second hour actually do 6 and 8. I'm pretty sure I had you cross them out, or just leave them blank for the time being. After doing all the other ones, after looking up the arc functions on their respective half circles, do you think you could puzzle out how to use the order of operations to simplify those before I just tell you how to do it? Order of operations, very first thing, parentheses. Take care of what's inside the parentheses. Work your way inside out. I want you to try those two. Paying very close and careful attention to what quadrants am I allowed to be in? Okay? In this case, yes. Okay, if you got the unit circle in front of you, or you memorized all your ratios, should be fairly quick. What's cosine of pi over 3? A half. So if I take this in stages, now I have the arc cosine of 1/2. What quadrants am I looking in with arc cosine? 1 and 2. So I look anywhere in quadrants 1 or 2 that has a cosine of 1/2, and it happens to be at pi over 3. That should seem pretty intuitive because remember, a composition of inverses results in the identity. If I do the arc cosine of a thing, it should come out as thing. But we're going to go into when that changes. Cosine of pi over 3 we said was 1/2. If I start mixing and matching things, now I'm saying find the arc sine of 1/2, and it ain't pi over 3 anymore. Pi over 6. Okay. What quadrants is arc sine restricted to? 1 and 4. But when I'm down in quadrant 4, we got to be careful. Use negative angles instead. Okay, and that was that trig cheater that we had. I had said I always have my second separate semicircle here that has all of my angles written out as negatives, just so I don't have to goof that. Okay. So if we can do that, graph. We did the whole theater thing and stick figure Steve watching the TV, right? Okay. So we're going to pick up with that kind of stuff. You have to just know, I can take the sine or cosine of anything. They have a domain of all real numbers. I can get any value -1 to 1. But for the arc functions, I can only take the arc sine or arc cosine of -1 to 1, and I can only get a value out for my range somewhere in that those two words. Somewhere in those two quadrants, that semicircle. Now here's why. -1/4, that's not a value on my circle, is it? Go all the way back to section 4.1. Could you find that angle? Arc sine is restricted into what two quadrants? If it's in 1 and 4, and that's a -1/4, what quadrant will this triangle be in? So draw your arbitrary triangle. Doesn't have to be to scale. I put my -1 here, my 4 here. I could do Pythagorean for my missing side, but it doesn't matter. Because arc sine of this gets me theta. Theta is ugly decimal angle. What happens now that I have ugly decimal angle when I take the sine of ugly decimal angle? I should get -1/4 because those are reciprocal functions, right? I should. Honk honk. No buzz buzz. Now I say should because sometimes things end up a little different. What's the tangent of pi over 2? You can't do it. So even though we would think arctangent of the tangent of pi over 2, well, those are inverse functions. They cancel. I can't take the arctangent of undefined. You can't put no in for a value. So it can't be found at all.
Undefined because it's greater than 1?
No, because the tangent of pi over 2 is undefined. You're trying to take the arctangent of right? Like it's not a number, it's not real, it doesn't exist. So I can't take the arctangent of waffles. Sine of 7 pi over 4. Is it a legal target? I can take the sine of whatever I feel like. Head down to quadrant 4, look at 7 pi over 4. Sine value is what? I'm now taking the arcsine of that. Now that I'm in arcsine, I have to be careful. Is this a legal target for arcsine? Is negative square root of 2 over 2 a value between negative 1 and 1? Yes. Okay, what quadrants am I looking in? So down in quadrant 4, I have an angle that is negative square root of 2 over 2. But I can't just cancel these and say 7 pi over 4 because arcsine is from negative pi over 2 to pi over 2. So negative pi over 4. Because I'm in quadrant 4 and I have to rewrite those using my negative angles. Because that way my domain, or sorry, my range will go from negative pi over 2 to pi over 2 in a clear number line. So I can't just see arcsine of thing, cross it out and just write the thing. I have to make sure that I'm using legal values. So do the thing, but make sure that the thing is legal. Okay. There's some life advice for teenagers. I like that we have an increased number of kids who got a separate unit circle on hand, so you don't have to keep flipping back and forth. That's smart mathing right there. Student looks up sheepishly while flipping back to old circle. Okay, is it a legal target? Can I do that? What quadrants am I allowed to be in? Remember what your domain and range are for each of these. What are my inputs? What are my outputs? What are allowed for my inputs and outputs? Not everything is on the unit circle. Remember that first one I did, that wasn't on the unit circle. I was still able to figure it out. This, you just dump in your unit circle or your calculator, you get this, right? When I do arcsine, what two quadrants am I allowed to be in? So you have to look in quadrant 4 for this. You can't get 2 pi over 3 back out. So, You know, if you want everything as all-in-one, here's an idea. Notice that arcsine and arctangent were quadrants 1 and 4. Arccosine quadrants 1 and 2. I could just make a 3/4 circle using those 3 quadrants, labeling quadrant 4 negative, and then arc cosine is only quadrants 1 and 2. So I could put my 1 square root of 2 over 2. That's the other one. Go over there. My square root of 3 over 2, my 1/2, my 0, my square root of 2 over 2 negative. I did it again. Negative 1/2, negative square root of 3 over 2, negative 1. Only fill in my cosine values in those 2 quadrants. Only fill out my sine values in the 2 quadrants they go into. So I'd have 1, negative 1, have my 1/2, negative 1/2, square root of 2 over 2, negative square root of 2 over 2, square root of 3 over 2, square root of 3 over 2. I did it again. And then my tangents on the outsides of where they belong. No. No. Negative 1, 1. Square root of 3 over 3, negative square root of 3 over 3, square root of 3, negative square root of 3, 0. You see how if I leave certain spots blank, if I leave this blank, 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 because there's no sign values there, I know that can't be my answer. Because there's no cosine values there, there, and there, I know that that can't be my answer. It's an idea. I had a kid do that last year, 2 years ago, because then it cuts it down to the relevant information. Instead of doing 2 separate semicircles like that. So, along the way, Arctangent of pi over 3, is that a legal target? What's the domain on arctangent? Domain. All real numbers, right? Arctangent is a graph that goes like this. So that's a legal target. I don't know what I'm going to get. It's some nasty decimal, right? I'm not taking the tangent of pi over 3. I'm taking the arctangent of pi over 3, which is not a ratio that's normally on my circle. So I'm going to do arctangent of this, and I'm going to get some angle. Okay, go take the tangent of that angle. What should happen? Pi over 3. That's one of the ones where they just nicely cancel out. Cosine of 3 pi over 4. Cosine is in quadrants 1 and 2. Go to 3 pi over 4. Get negative square root of 2 over 2. Now take the arc cosine of, cosine is everywhere. Now take the arc cosine. I'm only looking in these quadrants. It has to be that 3 pi over 4 again, because that's the only negative root of 2 over 2 in the 2 quadrants I'm allowed to be in. But this guy, sine of 2 pi over 3 is square root of 3 over 2. But when I do the arc sine of that, I can only be in quadrants 1 and 4. Where in quadrants 1 and 4 do I have square root of 3 over 2 as a sine value? 1 pi over 3, not 2 pi over 3. So you have to be careful about which quadrants you're looking in, whether it's legal or not. Now you notice all of these, it was a tangent with, it was a trig function with its reciprocal. And then I start mixing and matching. Is that a legal target for arctangent? Yeah, everything. Is 3/4 or negative 3/4 one of the special ratios on my unit circle in quadrants 1 and 4? No. So that means it's not on my unit circle. I'm just going to make the triangle. I am going to put it down in quadrant 4 though, because the negative tangent value tells me it has to be. I get a negative 3/4 as a tangent. That tells me 3 and 4 are my opposite and adjacent. It's in quadrant 4 and that was a negative. What do I have to change? Negative 3. And in order to find the cosine of that angle, whatever it might be, I need to do Pythagorean to find my missing side. And now go do the cosine of that angle. Now the cosine of that angle is adjacent over hypotenuse 4/5. Now this one wasn't on my unit circle, so I had to draw the triangle. What happens if it is the cosine of the arctangent of, instead of negative 3/4, it's negative root of 3 over 3? I check to see if it's a legal target. Yes. I look in what 2 quadrants? Look down in 4. Is that one of my special ratios? Yup. Okay, I can do this now. Arctangent of that. And I end up with negative pi over 3. Okay, now go do the cosine of negative pi over 3. Okay. A positive 1/2. So here's an example of it's not on my unit circle. I got to make the triangle. Here's an example, it's on my unit circle. Just look stuff up. Okay? Depends what information you're given. So one of them appears to be on the unit circle, the other one is not. One of them you can look up, one of them you draw the triangle. Okay, make sure you're looking in the right quadrants. Make sure it's a legal target. Draw the triangle if you need to. If you have to draw the triangle, make sure it's drawn with the correct quadrant so that you get your signs right. For part B, be careful with just doing Pythagorean theorem. Noticed as I was grading all those tests, there are some of us that are screwing up Pythagorean theorem. Okay, round one. Sine of pi over 3. Is it legal? Yeah, it's just any old angle can go into sine. Sine of pi over 3 was square root of 3 over 2. Okay, now go take the arc cosine of that. What two quadrants am I looking in? Look in quadrants 1 and 2 for a cosine value of square root of 3 over 2 and get pi over 6. Get that unit circle in front of you. Okay. Arctangent of 5/12. Is it a legal target? Yep. Is it one of my, okay, which two quadrants do I look in for arctangent? I look in 1 and 4. Do I have a special ratio of 5/12 somewhere in quadrants 1 and 4? So it's not a special ratio, you just got to draw the triangle. Tangent is opposite over adjacent. Because it's positive, it'll be in quadrant 1. Do your Pythagorean theorem or know your Pythagorean triples. And now, if that's theta, arctangent of thing will get me this angle. Now find the sine of that angle. Opposite over hypotenuse. Yep.
So when we're drawing the tan, it's only going to be 1 and 4.
Yeah. Well, it is still arctangent, so I know that my triangle will only be in those quadrants because that's its legal range of values. Okay. So in my experience, this one is we get it, but we need a little practice because of all the swapping. So go forward 2 slides. I want you to try these 2. It's just the order of operations. Go find the arc sine of 1. Go find the arc cosine of a half. Subtract those 2 things. Then find the tangent of that angle. Okay, do them in the order of operations. Work your way inside out. Hi. All disclaimers apply. If you need to go in the bathroom, go to the bathroom. Any risks taken while in the bathroom are entirely on you. Okay. Oh, why y'all are so quiet? Arc sine of 1, is that legal? What quadrants? 1 and 2. Looking quadrants 1 and 2. Where do I see a sine value of 1? Pi over 2, or 90. Go find the arc cosine of 1/2. It's a legal target. Quadrants 1 and 2 instead of 1 and 4. I get pi over 3. What is pi over 2 minus pi over 3, or 90 minus 60? Pi over 6, or 30. So if I'm at pi over 6, now go take the tangent of that. Okay? So let's just do the order of operations with these. Arctangent of negative root of 3 over 3, is that a legal target? Yeah! So I look in quadrants who and where? 1 and 4. Down in quadrant 4, negative pi over 6. Negative pi over 6, not 11 pi over 6, has a tangent value of negative root of 3 over 3. Now take the sign of that value. Negative 1/2. Okay? So, if it's on the unit circle, we're usually pretty solid. If we have to draw it out, it's just like section 4.1. And then we get into, I know you didn't do it, but in geometry, you're supposed to get, especially at the back half of the course, a lot of algebraic proof. Algebraic proof is where I show things with algebraic manipulation that this is true for all cases, and it's left in variable soup. I don't have specific numbers, but I can still do the thing, so later I could plug in numbers. This is a prime example of that. Write the tangent of the arctangent of A as an algebraic expression. That does not involve trig functions, meaning I can't have tangent of the arcsine of A. I have to turn it into alphabet number soup. So how do I do that if it's just A? It's not 1/2. It's not 5/12. It's not square root of 2 over 2. So arcsine, what two quadrants would I be in? So look in quadrants 1 and 4. Is A one of my special ratios? No. So I draw the triangle, just like I did for that 5/12 down there. So if I have to draw the triangle in quadrant 1, I draw arbitrary triangle in quadrant 1. I'm going to find this angle by taking the arcsine of A. A is who over what? So use that. Opposite over hypotenuse. Opposite over hypotenuse. Do Pythagorean for the missing leg. It's going to be left as a variable. Remember I said if a squared plus b squared is c squared, if you don't want to rearrange it every time, then the hypotenuse, square root of leg squared plus leg squared, which one is which doesn't matter because addition's commutative. If I want a leg, it's a square root of the hypotenuse squared minus a leg squared. I'm trying to find a leg. Yeah. It just stays ugly like this. Hypotenuse squared minus leg squared. Do not, don't you dare try to take a 1 or an A out of there. All the way into PreCalc, I still got kids doing that. I can only take factors out of a radical. These are addends because I am adding, subtraction is a lie, two things. So it just stays there. It's true, we don't subtract, we add the opposite. I don't divide, I multiply by the reciprocal. They're not defined algebraic functions. You get further in math and you actually prove that they do not exist. Because they're not bound by rules like associative, commutative, identity, those types of things. Yeah, we've been lying to you since elementary school. Yep. So, I mean, you could, someone says, okay, what's 15 minus 7? Doesn't exist. Huh? But 15 plus a negative 7 is 8. And then they think you're a pedantic jerk. So, now I'm going to find the tangent of that angle. Tangent is opposite over adjacent. A over the square root of 1 minus a squared. No radicals downstairs. They stir up girls, give them bad ideas. We have to rationalize that by multiplying by 1 minus a squared, square root of 1 minus a squared, for a final algebraic answer. This is the answer. That the tangent of this angle is square root of a square root of 1 minus a squared all over 1 minus a squared. No, you cannot cancel those a's. I can only cancel out or reduce factors. That's an addend. It stays that ugly. That is the answer. Okay. This is what I mean by algebraic proof. When I taught geometry, this exact example was in there. Okay. I should be able to do Pythagorean theorem with algebraic expressions. I might not like it, but I should be able to do it. So for both of these, make your triangle, put x and 1 in their respective spots, and then go find the other function of it, simplify it wherever possible. Okay, draw your arbitrary triangle. Don't worry about whether a, or in this case x, is positive or negative, because it'll work out in the end whether it's positive or negative. There we go. Do colors again. Do you at least have your triangles right? Arc cosine of x. Cosine is adjacent over hypotenuse. Put the x and the 1 in their respective spots. Arc sine of x. X over 1. Put x and 1 in their respective spots. After that, if I take the sine of this angle, it's opposite over hypotenuse. Done. That over 1. Next one, cotangent. Cotangent is adjacent over opposite. Well, here's adjacent, here's opposite. Square root of 1 minus x squared over x. Done. You say, why do I do this? Next year, you're going to be doing a lot of trig identities and coordinate proof in trig. And this is kind of the basis of it. That I don't need to have numbers in order to math. The law still applies even if the identity is unknown. Okay, I can still math with stuff that isn't a bunch of numbers by following math law. And you are getting to that part of math where there's going to be less and less number manipulation and more proof. The further you go on in math, it's more about, can you prove that this works in all different contexts? Because now I can apply it to all different contexts. And that's what allows you to go into the weird realms of things like integrals to find volume in an odd-shaped container. That's when I can start doing stuff like projecting different models on a curve, because now I know my rate of change along that curve. That's how you can do stuff like, you seen someone sent me the meme about I've never used trig again in my life or something, or I now know SOHCAHTOA, I can forget it. Something like that. You ever seen a construction crew or them starting to get ready at a survey site? The actual survey person who's walking around with their little orange vest, and they got a little tripod and a little scope on there. They're doing basic trig like this to determine elevation, to determine the gradient on, you determine the gradient on the hillsides, whether something's actually going to be level or not. How many of you have a home that's built into a hillside? Okay. They have to place the weighting of it structurally at a certain point in the hill as it's carved out. I can't just cut a hole and build house. Like, they actually have to weight it a certain way because the hillside will slowly over time exert pressure onto the house. They're doing basic trig to figure out how that works. Okay. Where's my shooters? Okay. If you do any sort of competitive shooting, you know trig inside and out, forwards and backwards, and you actually bring a calculator and notebook with you. Okay, you ever seen a documentary on snipers, sniper school? Okay, it's all math. It really is. Are we okay with it, or do we need to see it again? Yay, nay? All right. Then, I said we go straight into 4.7. The law of signs. The law of signs is derived by doing algebraic coordinate proof on things. I have triangle. Do y'all remember what this is called? Altitude. Okay. Altitude is the height. Now, depending on the triangle, the altitude doesn't have to be inside of it. Remember, if I have an obtuse triangle, the height or altitude can be out here. Okay. So, maybe some big honking letters and notes and words to yourself at the top of this. You cannot do right triangle trig to a triangle that isn't right. You think that would be common sense, but I'll have a kid come up to a problem like, I'll have a kid come up to a problem like that on their test, all the way into PreCalc. They do Pythagorean to find this. They subtract from 90 to get this, and they call that 90. You cannot right triangle trig something that's not a right triangle. However, you can use right triangle trig to create the laws for non-right triangles. If I wanted to find the sine of A, do not be a freshman and say the sine of A is little a over little c, because that ain't a right triangle. So don't do that. Instead, we drop this altitude in here. I'll call it h for my height. Now could you find the sine of angle A? Opposite over hypotenuse. H over C. What about the sine of angle, no, not B, C. What's sine of angle C? Right? Opposite hypotenuse. What do these two have in common? They both have the same opposite. They both have an H. So if I were to rearrange them, Jesus fish style, get H is C times sine of A. Cross multiply, get H is A times sine of C. Well, if H equals stuff and H equals stuff, they equal each other. And when I say that C sine of A equals A sine of C, I could clean that up. I'll divide both sides by C. I'll divide both sides by A. And I get the sine of angle A over side A is the sine of angle C over side C. And I can take this triangle and flop it on its head, and I can show you the same thing is true for angle B. That's the proof of it. That's how this came about. There it is in practice. That's your law of sines. The law of sines states that the sine of any angle over its opposite side is the sine of any other angle over its opposite side. That allows me to start solving triangles and finding missing values of non-right triangles. First up, you remember all the triangle congruence and similarity theorems? Angle, angle, side. Side, angle, side. Side, side, side. There wasn't angle, angle, angle. That's just similarity. And there was no ass, unless it was a right ass. Because then you have a right angle and you actually have side, angle, side, because of that extra right angle. Okay, be prepared for a lot of that these next 2 days. For angle, angle, side, likey this, in order to solve my triangle, I'm looking for what I call the control pair. The control pair is when I have sine of angle whatever over its opposite side. Do I have a control pair of this angle and the side across from it? Okay, so this is my control pair. So I could now find little a by comparing those as a ratio. I can say the sine of 103 over 20 is the sine of 35 over little a. Now, you can cross multiply and show all your work if you want to. Multiply these two. 20 sine of 35 is a sine of 103. But then you have to divide to get a by itself. Like that. I don't want to write all that out. I've shown you before with basic ratios, I do this all the way back into algebra half. Jesus fish, alpha. You multiply the two that line up and divide by the one that doesn't. Okay? And then you get goldfish, the snack that smiles back. Okay? I can now say that little a here is 20 sine of 35 over sine of 103, which I do want you to write as its simplified expression. And then give me the decimal equivalent with it. What mode should we be in? It does matter. Why? Why should I be in degrees? It's got degrees. Don't give me two angles in degrees and then go find another one in radians. Okay? So, ballpark, how much is it? That's 3 places? Always 3 places. Because this is where my 3 places rule came from. Okay? Doing right triangle trig and law of sines and cosines on things with freshmen and sophomores in geometry who could not handle those expressions is where the 3 decimal rule came from. Because if you use a decimal out to 3 places, even some of our bigger, uglier problems, like when we hit the 2 triangle ambiguous case, it's still pretty flippin' close. Okay? So that was one of them. Can I find another? And say, well, wait a second. I got nothing. Yeah, triangle sum theorem. All triangles add up to 180. 103. No. That was something. 103 plus 35. 138. God, I even sound like Grandpa. 103 plus 35 is 138. Subtract from 180 and get 62. No, 42. If I've got that angle, then I can set up the other ratio. Sine of 42 over little c. No more goldfish this way. Goldfish go away. Multiply the 2 that line up, divide by the 1 that doesn't. Little c is going to be 20 sine of 42 over sine of 103. Should this be bigger than 11 or smaller than 11 before you press the buttons? How do I know? Triangle proportionality theorem. The bigger the angle, the bigger the side. Okay? It should be bigger than 11.773. It should be smaller than 20 because it's the middle-sized angle. How much? 13 change? Okay. So the way that you're going to write these, expression, approximate, decimal. Make sure you have the expression. Because if you only have the decimal and nothing to back it up, what happens when you are in radians and your values are completely off? Okay. Now also, as we get to these, you're going to see I don't have any of that written. I just go straight to this. Because the shortcut for it, you notice they were both over sine of 103? They both had 20 on the numerator. If I'm looking for little a, I'm always going to have little b sine a over sine big B. every time. Because that's just how the Jesus fish works out. That's how your cross multiply and divide works out every time, regardless of the variables. It doesn't have to be A's and B's. It's just, in this case, the B's are whatever my control pair is. Okay? It's going to end up that way every time. Dang, dude. Must have been a powerful breakfast burrito. Okay? Try it. You know what? Do them both. That should give me about 3 minutes. Do them both. No one burn anything. Class mom's in charge.
I'll be it, guys. I'll be the last one. I'll pretty much have the mom. Sorry. Jeez, my bad. Yeah. Yeah, I don't either. But anyway, he says that answer. Dude. same problem.
Technical difficulties.
Yeah. I'm getting my butt kicked.
Over sine of 63, not just 63.
Oops. That's what I'm getting.
Because you're dividing by 63, whereas the sine of 63 is like 0.7.
Oh.
Okay. So it's at 110, 114, order 66. Identify your control pair. And now, little s is 13. Okay. Now, if you want to write out sine of r over r equals sine of t over t, if you want to do that, go for it. This is how I'm going to write stuff out because, again, this should be the second class that we've done them in. We know how to solve proportions. Okay. Give me the ballpark on S and T. Let's make sure they fit our proportionality. About how much for T? Confirm? Bobbles. Okay. How much for little s? 339. Confirm? Bobbles. Okay. So you identify your control pair. If you need to write out that the sine of 63 over 13 is the sine of 66 over t, and then cross multiply and solve, you do it. If you need to write out sine of 63 over 13 is sine of 51 over little s, go for it. I'm not going to put yellow on there because we passed geometry. If you need to write yellow, write yellow. Sometimes I need to count on my fingers. Use what you need to, right? Put things in alphabetical order. I dare you to put things in alphabetical order without at some point singing part of the ABC song. Right? I know there's a song. I have never had the song in class. Ew. I am not a singing folk. Did you do this one too? Okay. We should have measure of angle K is 180 minus the sum of 29 and 25, which is 54. So 126. Right? I can't do basic arithmetic. I can do everything else. And then we should have our control pair. If this is my control pair, everything else is dependent upon that. You could also write it as a triple proportion with just that in the middle. I could say the sine of 126 over, that's not my control pair. There's a control pair. All right, I can say sine of 126 over k is sine of 29 over 18 is sine of 25 over L. And then I could just double Jesus fish. Multiply the two that line up, divide by the one that doesn't. Multiply the two that line up, divide by the one that doesn't. Okay. Well, now it's like two fishes made of Play-Doh that like ran into each other and smushed heads. Okay. So we should have k is 18 sine of 26 over sine of 29. We should have L is what? 126. 126 over sine of 25. Yes. Okay. Ballpark, what are they? They should be pretty close because their angles are very close too. L is going to be what? 17 something? 16 something? 15.6 blah, 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 blah. Okay. It shouldn't be too far off of the 18. And then K was going to be a lot bigger than that.
30.037.
30 and change? Okay. Once you get here, it's just pressing buttons. I'm assuming you know how to press the buttons, so we're good. All right. The reason you need to know that is there's usually some word problem context with it. These are literally blah, 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 do the same thing you just did. Okay. Orbiting satellite passing between Oak Ridge Laboratory in Tennessee and Langley Research Center, Langley satellites, which are 446 miles apart. If the angles of elevation are this and this, how far is it from each station? Langley, CIA, no? Anyone?
I'm so lost.
Langley is the CIA headquarters and research center. It's also their training grounds, West Virginia. So, blah, 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 they give you this stuff. Do you see just the regular old triangle? The context of the problem doesn't matter. Would you be able to draw that triangle from what they said? They said there's two things that are 446 miles apart. They said there's a satellite above them. The all-seeing eye of Sauron. And the angles of elevation to each are 58 and 72 respectively. Can you draw that picture from the information in the problem? Okay. So once I see it, I can say, nope. Measure of angle C is 180 minus 58 plus 72. It's 120, 130, 50. I now have my control pair. The irony of the control pair being the satellite in the sky is not lost upon me. And then go find this distance. Little a is sine of 50 over 446 equals sine of 58 over little a. Jesus fish your way through it and get 446 sine of 58 over sine of 50. If you need to write sine of 50 over 446 is sine of 72 over little b, Jesus fish, and then write, that's fine. 446 sine of 72 over sine of 50. Okay? So if you need to write it out, go ahead and write it out. But that's all I need on there. And then, of course, give me their decimal approximations and make sure you're in degrees because that's the angles you were given. I'm guessing they're going to be big numbers. 200 something. Like, they're going to be big. I mean, you're talking about something orbiting above the Earth. I'm guessing it's a couple hundred miles up there. Okay. If it's not, or if it's not a couple hundred miles up there, well, then that's not a satellite. It's a drone. So, yep. There you go. Same thing. Ships approaching port. Hopefully there's not a sandbar. I'll get stuck for a month and a half and end up on the news. I saw so many memes with that ship stuck in that canal, and they like changed the name on it to just say "Ever Stuck."
These are agencies around the world watch lots like a collective hunter killers.
Yeah.
From like a really is an artist for real trade.
It's already drawn for you, but could you draw the triangle from the information you were given? That's one of the biggest things that physics students come back to me for help with, is they just don't know how to draw the stuff out. Got them? Okay. Subtract from 180, get your angle. Once you got your angle, you have a control pair. You have the control pair, you set up your ratios. Tomorrow, when you come in, we're going to start off with the ambiguous case for these. The ambiguous case is the reason you never had an angle side-side congruence theorem. Because it turns out that if you got a cute ass, you're in trouble.